Okay, today we're going to make a program that calculates the roots of a quadratic equation using the quadratic formula. So, make a new project. We call it quad formula. Hopefully you should be getting more accustomed to this sort of creation of new projects and classes so far. We're just going to call it the same thing. Keep in mind that as we go on and get more and more complicated projects, the name of each class is not necessarily going to be the same name as the project. We'll have more than just one class. But for now, it just makes the most sense to name it the same thing. Okay, so we're gonna take input from the user again. So we're going to import java.util.scanner and give ourselves a comment. Calculate the roots. Okay. Give ourselves some Java doc markup. Okay. So first thing we need to do is basically, so if you forget what the quadratic equation looks like, it looks like this. For a function with variable x, we have ax squared plus bx plus c. Right, so we have a quadratic term, a linear term, and a sort of constant or offset. So the things that can change in a quadratic equation are these coefficients a, b, and c. So we're going to get those from the user. So that's why we need the scanner. So we're going to let's declare some variables. Use our scanner. And we also need to declare some coefficients. And I'm making them doubles because they can be both integers and real numbers. It doesn't matter. And if a, b, and c were only integers, then we would be restricting a, b, and c to only be integers, which of course they don't need to be. So we're going to display a little intro message. Say now here, notice that there's more that I want to say here on this line, but I don't have enough space because I'm going to run into my 80 characters pretty soon. So what I do is I put in this new line character there, which doesn't print out that /n, but it just prints a new line, and then I'm going to continue my string here. So here this is just for the user, so the user can be reminded that of what the quadratic equation looks like. So we're going to quadratic formula finds the roots where f of x equals 0 for the function. There we go. Okay. And let's put in another character term. Notice that print line automatically puts a new line at the end of whatever string you put in here. But so here we're just going to have another one, which is just a little bit nice for formatting stuff. Okay, so let's get some things from the user. So we're going to say prompt the user for, we're just going to do it like this. Equals, we're going to use our scanner, and we're going to, instead of using next int as we did before, now we're going to use next double. And we're going to just copy this, which is the same for B and C. Okay. And now we need to calculate the discriminant. Which is, if you're forgetting, that's the square root function. It's b squared minus 4ac. And this basically determines the number of roots and the type of roots, whether they're real or imaginary, of our quadratic formula. And this is basically the thing that determines where, that sort of indicates where the parabola is on the in space, and whether or not it crosses the x-axis 0 times, 1 time, or 2 times. Okay, so let's make a little thing here. I'm going to call it discrim. And we're going to say discrim equals b times b. Now there is, we could use the math.power. Here you can see we can raise one thing, a raised to b, but that's a little bit more than we need since we're just using squared. It's just as easy to just do that. But again, it doesn't really matter. Okay, so there we're calculating our discriminant. And okay, so now, right, we're going to modify output depending on sign of discriminant. I hope I'm spelling discriminant right. I don't know. Okay, so what are our 3 cases are here, right? So if the discriminant, discrim, is greater than 0, then we should have 2 roots. 2, and I should say 2 real roots. Okay? And so we're going, let's actually go up and make some variables here. Double root 1, root 2, and we'll also make something called imag, which we'll use later. Okay, so root 1, this is, of course, again, if you're forgetting what the quadratic formula is, go back and read about it. I'm not going to address it directly here, but so it's negative b divided by 2a, and it's actually, so that plus, actually let's do it a different way. So we're going to do negative b plus the discriminant. Actually, right. So the discriminant, I'm sorry, the discriminant is that. It's not the square root of that. It's that. So we're going to do the square root, math.square root. Okay. So that's the first thing, and then we need to divide this whole thing by, now notice if we just did this, we just divided like that, we would be, basically be dividing this quantity inside the parentheses by 2 and then multiplying by a. So you got to remember your order of operations when you're doing this kind of thing. Okay, so there's 1 root. And of course, the other root is very similar, except that instead of plus, it's minus there. Right, so because it's negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so there are 2 roots. So let's print those out here. And we're just going to say 2 real roots, right? And they are root 1 and root 2, okay? Now, so the other case is if our discriminant is less than 0. Notice I'm using strict inequalities here. So here we also have 2 roots, right? But we have 2 imaginary roots. And the imaginary component is exactly this. Now, to be honest, I can't remember how Java treats square roots of negative numbers. Maybe it throws an error, or maybe it actually does give an imaginary number. I'm not sure. But since we know the discriminant is less than 0 here, it's negative. Therefore, we're gonna make it positive by putting a minus sign in front of it. So we know that this thing is gonna be positive, right? And then we're going to divide by 2 times a, right? So what this part here, this is the imaginary part of both of our roots that we're going to either plus or minus to the negative b over 2a. Okay, system.out.println. So we have 2 imaginary roots, okay? And our roots are negative b divided by 2 times a, okay? And it's that, it's actually quantity, negative b, okay, so there's that. And this is going to be, now we're going to say plus, and just because it's the same, we're plussing and minus the same thing, we're just going to go like that. And then we're going to print out our imaginary part. So, okay. So what this is going to do is instead of printing, root 1 and root 2 like we do up here, it's just going to print the real part of our imaginary number, which is this negative b over 2a, and then it's going to say plus or minus imag. Now, but what we actually want is plus or minus I, right? So to denote that this number here is an imaginary number. We've sort of forced it by using the negative discriminant to not be not be an imaginary number, but we actually know that it is. So that's why we put that I there. You'll see what I mean when we print this out. Okay, so finally, the easy case, right? So if our discriminant is not greater than 0, it's not less than 0, then it has to be equal to 0. And so therefore, we just have one root. And so we're just going to say root 1 equals negative b divided by 2a. Right? And this is easy because basically since our discriminant is 0, the whole square root of b squared minus 4ac is also 0. And so we can just say system.out.println 1 real root. Okay. So let's try this. Okay. So we're going to put in, oh, you know what I've done? See, look, I have print lines here instead of print. So let me stop this. Oops. Okay, there we go. Let's actually, before we start just typing in numbers here, let's actually come up with some examples so we can see whether or not our program behaves as we expect. This is sort of akin to coming up with hypotheses and then testing those on the program. So we're just going to do some simple ones here. So x plus 2, x plus 2. This implies that the expanded form looks like this. Actually, that. Right, which implies we have 1 real root at -2. Okay, so let's do another one, maybe x minus 2, x plus 3. Okay, so we FOIL this out, and we get -2x plus 3, right? That gives us x, and then -2 times 3 is -6, right? So this gives us 2 real roots at 2 and -3. And then just let's do one that's not going to factor so nicely. And I'm just choosing coefficients randomly here, as you can probably see. So this should be, so let's actually just apply the quadratic formula here to see what this is going to be. So this is going to be -3 divided by 2 times a, which is here it becomes 4. So -3/4. It's going to be plus or minus an imaginary number, okay? And the square root of that, so our discriminant is 9 minus 4 times a times c, which is 4 times 2 times 4, which becomes 32. So 9 minus 32 is -23. So we pull the negative out of the square root with the I here, so we get a square root of 23 divided by our 2a, which is again 4. Okay, so let's actually now test that. So we're going to test the first one. That looks good. Again, it's really important to sort of think about good testing of programs. There's a whole area of software engineering that's just solely based around testing, because even though a program compiles doesn't mean it works the way that you want. In many ways, the bugs in the program, it's easy to find bugs that prevent it from compiling. It's much harder to find what are called runtime bugs, and that's what the testing is meant to do. Okay, so now let's put in 1, 1, -6. Okay, so we get 2 and -3. That looks good. And now let's put in our non-factorizable one. Okay, so this is looking good, -0.75. Oh, we've got a minor formatting thing. I'm just going to add a space down there. And let's see if this, 1.19, etc., looks reasonable. So we're going to do 23 square root is that. And then if we divide that by 4, we get that. Okay, so that looks good. So our program seems to work, and maybe this will save you some time, but at least you sort of understand how to make a slightly more complicated program. Okay, that's all for today, and good luck in your future projects.